Welcome to IOQM problem solving session. So today we are going to solve a problem from IOQM 2024. Let us now solve ninth problem of IOQM 2024. So over here you have grid points. So this is interesting. You have grid points whose coordinates are from 0 to 4 and you consider all of them. So let's consider these points as our grid points. Now the knight move pair is a pair of 2 points for which a knight can make a move in the actual chess game. So you can think like this. If you are starting from this point, or let's say the middle point, you can go to this one or this one. For people who are familiar with knight moves, this question is actually a intriguing one because you are already familiar with these. So these are the possible 8 moves for a knight in chess. But here they are defining a more formal version of knight move pair by considering set of points that satisfies a plus or minus 2 and b plus or minus 1, or a plus or minus 1 and b plus or minus 2 as shown. So let's say you are starting from the center violet circle, then you are allowed to navigate to these circles. And these, when combined with this, the initial point, would form a knight pair. So the question is, how many knight move pairs are there in the grid points? We are given with 5 cross 5 grid points starting from 0 to 4. So let's think about it. Let's do some overcounting, but cleverly. So combinatorics mostly involve overcounting and undercounting as a part of solution. It does not mean that it's a wrong approach. It just means that you have to account for it. And it will take care of the careless mistakes. You will not be doing any careless mistakes. All right. So the idea is this. Consider the number of knight move pairs that contains this point. How many knight move pairs contain this point? Let's say this one and this one is a knight move pair, and it contains the bottom left corner point. And the first one with the point circled recently would also form a knight move pair. So there are 2 knight move pairs associated with this point. So let's mark the number 2. Similarly, if you consider this point, there are these many points, 1, 2, 3, that can form a knight move pair with the point in the small red square. So thus there are 3 knight move pairs associated with this point. So again, if you consider this one, you would get 1, 2, 3, and 4. But there are no more because the entire left side of it is empty, right? It's vacant. So it's 4 in number. And if you proceed like this to calculate, you can find all the numbers in this square that correspond to these 9 dots. But be a little clever here, because these 4 numbers will now repeat, because these 4 are symmetric to it. There is no variation to it when you change the perspective. And thus, all properties follow, and you will get essentially ultimately the same number, right, at the last. And similarly, these points would correspond with these points and these points and these points. So proceeding like this, one can write the corresponding numbers for all of them. So you get 3 for this and 4 for this, and you will get 6 for this, and here you will get a 4, and here you will get a 6, and here you will get a 8. And by symmetry, you can just reflect these numbers. You will get 3, 2, 3, 4, 4, 6, 6, 4, 3, 4, 2, 3, 4, 3, 3, 2. Now, what am I going to do with this? I have to find the total number of pairs, right? So here is the combination of the idea that we first discussed in regard to overcounting with all these numbers. How are we going to overcount with all these numbers? So add all of them. What does it give? It gives the number of night move pairs. It gives the number of night move pairs with each pair counted exactly twice. The reason being that if you consider this pair, then it is counted in the original sum with this one and this one. So the same pair is counted twice. When you take the counting in regards to the 4 and in regards to the 6, you count the same pair. So hence we count exactly twice. So if you add up all of them, you will get 4 times of 2 plus 3 plus 3 plus 4, which is 12, plus 4 times of 4 plus 6, which is 10, plus 8. So this gives us 88 plus 8, which is 96. And since each pair is counted twice, the final answer should be half of 96, which is 48. So hence, we overcounted and we accounted for that. So sometimes thinking in the wrong sense and going to the right direction will give you the solution.